So our very first acceleration problem. It's really not too challenging once you get the hang of it. So a roller coaster's velocity at the top of a hill is 10 meters per second. Okay? So we know for sure that's a velocity. It reaches the bottom of the hill 2 seconds later, so that's our change in time, with a velocity of 26 meters per second. Now take a quick second. Which one do you think is our initial velocity and which one do you think is our final velocity? So hopefully you're able to figure out when you see the word later, that would mean that whatever comes later will be our final, whereas this one is our initial. And now I'm going to change color. And again, this is kind of my approach to solving these problems. Acceleration is our unknown. So it looks like that. Again, all we got to do is now carry these variables down here just to get you comfortable with using the guess method. All right. So VI, oh, that's a different color blue, and that's going to kill me, but too late now. VF is equal to 26 meters per second, and delta T is equal to 2 seconds. Now, the only equation we know for acceleration up to this point has been A is equal to VF minus VI divided by delta T. And now all we got to do is look at our formula and compare it to our given values. So VI goes over here. I'll change the color. Let's do purple just because. VF will go here. We know A is unknown, so we just leave it as A. So 26 minus 10 divided by 2. All you got to do, A is equal to 16 divided by 2. This is meters per second. This is seconds. A is equal to 8 meters per second, or A is equal to 8 meters per second squared. This is the more common way to see it, and I think it's the better way to view it. But if you're ever confused about what acceleration is it's literally saying the velocity is changing this much, this value, per second. So it's 8 meters per second increase per second. So every second we get an increase of 8 meters per second to our velocity. So we start at 10, then after 1 second we're at 18, and then after 2 seconds we're at our final velocity of 26. That's literally all it is saying. Okay, now moving on, and you get to try your own little problem.